On this computer. There we go. All right, so this is being recorded. All right. So before we move on, does anyone have any questions? General questions before we start?
Oh, shoot.
Yeah, I was looking at the homework right now,
Mm-hmm.
and for MySQL, it said add a timestamp. Is that the same thing as a primary key?
No, timestamp is something different. So remember how we were able to create a timestamp from Firebase? It was actually a Unix-based timestamp that was generated on server side. So I'm not sure if that was covered in 14.3 that we didn't cover, but if it was, then I'm going to try and go through it today. If not, then there are solutions that I can give you for the timestamp. But essentially, it's just generating created at and updated at. Created at, updated at is always good to have. When you guys use Sequelize, you realize that it automatically does that for you. Because adding timestamps to each record is really important because it determines when it was first made. And then the updated at was when it was updated. So it's just information for you as backend engineers to determine how to best utilize that data and looking back on records of that data as well. So in terms of implementation, I'm going to see if we did cover it, but I'm pretty sure we didn't do that yet. Okay, so there's a question about the dot / So if you go to here, I've looked this up before. Why do we use dot / in require? And
modules if it's not dot /.
it basically some of them require dot / format, such as require. Other ones require process.cwd, and then other ones take in dir name. So it's kind of weird, but actually here. I had an article on that difference between that process, current working directory, and dir name. So there's a good article. I've seen several articles. And this is one of the ones I was referring to. I'm not sure if I slacked this out. So there's 3 different ways to refer to directories in Node.js. So there's dot notation, which is this, dir name, and process.current working directory. Well, all of them might seem to refer to the same thing. They become a source of confusion, bugs, if you don't understand them too. So if you have a directory called base, so let's say that we made so let's just say I do mcdir and I do base. So now I have a directory called base. And I have a directory structure that looks like this. So I did touch app.js. I did mcdir 1. I did 1.js. 1.js. Oh, shit, I never CD'd into it. All right. What the fuck? So let's just say I was in this directory and I created a structure that looks like this. So the content inside app.js is going to look something like this, where we have console.log, and I'm inside here. So log this file, and then we're using this to then, determine whether or not something exists. And we have a whole bunch of different ways of looking at the information. So this file, actually, this tutorial, I think it would be a little bit too long to go through, although I do think it's important. I think I should just slack it out and then move on, because I'm going to get back on getting stuck on reviewing things as opposed to going on with a new material. So let me just slack this out. Because we ran into that issue yesterday. So I don't want to run into that again. So where we start off was we were reviewing how to create an Express application with handlebars and MySQL database. And we went into depth in how to implement that. And essentially, we reviewed mostly how to implement that, because we covered that all week, and then we went over it again on Saturday. So we have our application, and if you take a look at Saturday's class, so I pushed everything up. And I think it was just exercise number 1. So if you look at exercise number 1, we had all the information in there. We went and we basically went through it. At this point, I think you guys should definitely be able to do this. We went through it. We've done this. If you guys have questions about it, we can do one-on-one sessions. But otherwise, what we're going to do is we're going to start moving into the ORM part. So I briefly went into using ORM. So we use this ORM example. And what this did was, it's an object relational mapper. So what this did was it took this object, ORM, and this ORM object acts as a mapping tool to our database queries. So if we have our ORM object, we can actually go to our config, orm.js, and notice that we have our orm.js. Sorry, someone's like at my door. Give me a second. Hello? Hello? That's really weird. Someone opened up my front door and then walked away. All right. That was really weird. I have 2 sets of doors. The front one's the security one. They opened that, and then he walked away. Okay. Anyway. So we have this ORM object, and this is basically mapping out the different methods that then pertain or have basically like a relationship with your different SQL queries. So whenever you call these different methods, it's going to execute a SQL query, or it's going to execute some kind of search, right? And this doesn't necessarily need to be a search. It could be any kind of query to our database. So I have select where, select an order, find who has most. I think this person's going around my house. This is weird. Oh, people. No, don't worry. I got it locked. All right. So we have select where, select an order, and then find who has most. And query string is essentially select everything from somewhere else. And Whitney was good enough to let me know that this double question mark is actually just representative of column and table name, whereas the single question mark is just for values. So if we take a look at this, this is all something that we should understand by now, this part right here. Combining it with this concept of using methods for encapsulation. So remember, functions can be used for essentially two purposes. One is input output, another one is for encapsulation. What we're doing is encapsulating and using it for input output. Now, our input in this case is going to be from the table input, column to search, and value of column. Now, we want to do it this way because it becomes really messy to keep writing out large string queries. Instead, we obfuscate and modularize our application so that we have very simple SQL queries that are then mapped to objects instead. And then that way, we can also perform a lot of data validations in them as well. There are also some other benefits that you're going to see from Sequelize, where everything is mapped to a model. But essentially, we're doing the same thing. When you execute this, you're still doing the same thing, which is you're making a CRUD query. So the question was, where do you do the data validation? So that would be in the ORM itself, right? For right now, we're going to think about it in the ORM itself. But generally, you would be doing that first as a layer through the ORM. And then when we start using models, which we're going to go over today, and then we're going to start going into further on Monday and Tuesday, you're going to see that we're going to have data validations built into there as well. Now, data validations, you can first say like, okay, well, I need to clean up my data first, and then that data needs to be put in to my methods. So you could say, okay, well, the first layer of validation should always be on from where? Where can someone think about data validation first occurring in your application? Middleware is a good guess. I'm thinking even before that. User input, exactly. So your user input should be validated on the front end. However, that can be overridden because of JavaScript on the front end. That can, someone can just say like override this JavaScript input. It's like, okay, cool. Maybe we get some crappy data validation overridden, and then that data gets sent to the Express server. Now from the Express server, then you can have some middleware like Juan was mentioning, and then you could clean up that data even further. Now, generally, middleware is not usually used. It could be used for data validation, but I like to be more explicit with my data validation, very much so in my controller when I get to that controller logic. Now, I would say you can do it in your model as well, and we're going to get to model and controllers. But for now, I would think about just doing it here in the ORM. So you can have multiple layers of security, where it's like someone tries to like hack and put in like some SQL injection that is trying to get all the information from a database, or maybe even just destroy a database or corrupt your data. And you can have multiple layers of validations that basically say like, hey, is this data cool? All right, if it is, send it to the next security guard. All right, now next security guard, middleware, check it. All right, cool. Is it cool? Then it's like, go to the next security guard. It's like, okay, now we have our controller. Controller sends it to model. Model, is it cool? Model's like, I don't know. Yeah, I guess so. And then controller's like, cool. It's like the TSA, except it actually does its job. So we have all the different methods here, like select where, select and order. And we don't really have any data validations on these, but it would be good to have data validations. So when you guys do your homeworks, I'd be really happy if you guys did some basic data validations. And there's so many libraries already available that can do it for like, SQL and things like that. But later on, we're going to see how like Sequelize will take care of a lot of that as well. So first, we have this object. And again, all it's doing is mapping these different queries. So we have all these different queries being executed. And again, because they're asynchronous callbacks, we then get the results once it's finished, and we display it as soon as it's finished. But notice that when we execute it, it's doing it, but we're passing it in, and then it goes here and it executes it. So this is a really interesting example of like going somewhere else and kind of like, you know, it being kind of confusing to follow it through. But this is essentially the same thing as if I were to create this object and create these methods over here and then execute them just on the bottom. So it might be like, wait, why do I have the availability of using these here? Why can I execute it? Because it's located somewhere else. Well, remember that you can always just go to the file itself. So one of the directory structure methods that we're able to use is this ./config and then orm.js. So what it does is it looks at your topmost directory, which is dot, then it goes down to config, and then it says orm.js, and then just includes this file, right? So again, we've done all of that before. Any questions up to this point about how we included this file, orm.js, what we created, what is this object, and what do the methods represent? Jared, yes, that is correct. A single dot will refer to the topmost directory. As long as you have the / dot will go just up one directory from your current location.
Is ORM a package or is it just a concept?
So ORM is just a concept.
Mm-hmm.
So object relational mapper, again, we just created our own object relational mapper, right? Top as in root, yes. The root of our application though. So we have this ORM object, we are just representing it. So right now we're just using this concept of object relational mapper, right? Like we didn't create anything really complicated here, right? All we did was create this object, and you guys could have created your own object relational mappers, right? You could make your own ORM, do whatever the hell you want, etc. So another thing that we did is we started modularizing our application, which started off with public views, and we had these SQL files, right? And we had all of our authentication information all in the same file. Now, this file, however, is not meant for, you know, holding credentials and holding all this other information. It's meant to just run our application and serve as a conduit for our middleware, and then also to route to our application as well. That's what the server.js or the app.js is meant to be. So if that's what it's meant to be, then we can take out all this fluff, which is, you know, let's see this, MySQL, we can definitely take that stuff out. So we just copy and pasted this into its own file, and we called it connection.js. And you definitely do, you're gonna see this a lot in like PHP, Rails, like whatever, you know, large scale application you're using is gonna be. And again, you have this like separation of concerns. You have this ability to then, you know, update this file without necessarily updating all other files. So if someone commits this, it's not gonna like, you know, ruin everything else. And if someone's working with a database, they're just working with database files. So it becomes a lot more scalable, and it's a lot more clean too. So now instead of our server.js having all that fluff inside, I know this one is a lot more bare bones because it doesn't include Express. But imagine just even in this, just, you know, not having all of this in there, you know, and then hopefully modularizing some of the rest of it out as well, so that only Express server related, middleware related, and routing related information is in this application, and everything else is in a different file or different files. So we have this connection.js, and it's doing the exact same thing. Remember that we're just saying, hey, require MySQL. We're just connecting to our database. We're just putting all the information there. And then our ORM.js is actually the only one connecting to this connection.js. So we don't even need to know about it when we're running a server.js. Questions about that? Okay, cool. Remember, if you guys have a question, just like, I don't know, put question, and then that way you can take time to like write out your actual question. All right, so from there, we also modularize our SQL files. So our SQL files were, again, schema and seeds. Schema sets up our structure. Seeds will populate the database with information. If you need to do this, we put this in our database folder. So this database folder now contains the schema and SQL. So this isn't, any programming. Literally, I created a folder called DB that just contains my database stuff, right? So now I have this structured a little bit nicer than something like this. Is the hierarchy of export require files used here? Used here similar to what we will see with Sequelize. So what you'll see with Sequelize, if you guys actually want to take a look at an application that uses Sequelize, again, go to Travel Secure. I'm going to be updating it more and more, but here's the link. I just need some time to work on it. I just have not had the time. So the database fits in with MVC, and we're gonna go into that today. Don't worry. Just don't want to cover that immediately right now. We're gonna get into it like in, I think, 9. So let's see. I have the ORM example, and I went through that. Okay. So now we go to example number 5, which is Holiday Planner. So Holiday Planner is an application that does some complex queries. So it has the same structure. So it has a schema.sql, seeds.sql, our node modules are in here, our package.json exists, and our server.json has the same configuration as well. Now again, this server.js, it does not contain Express. We're just working with the database for right now, and we're just, modularizing the database. We're then going to incorporate the Express application, the Express server, after we go through this. So again, this connection, same stuff. ORM. Now, this is just a more complicated ORM, right? So instead of us just, running simple SQL queries, this now has some error corrections. So if we have some error conditional statements that catch errors, we're also doing some more complicated queries. Let's see, what to select. So what we did over here was, instead of putting this query directly into this, we separated it out. That's not really necessary, but you could do that too, just to make this a little bit cleaner. Notice that because of the MySQL module, we have the ability to then pass in values that are going to be replacing these parameters. So the parameters are going to be the columns that you want to gather from and from what table. So we're passing that in. So this is similar to what we saw before. So select, to execute that select statement, we just do select and we pass in what tables we want, what columns we want, and then what values we want. So that's pretty clean. Now, if you want to execute select from where, again, similar concept. Now, if you want to select and combine different elements from different tables, you can actually do something called joins. So joins are really important. And let me see, SQL joins. Let me send out a video actually that I think I found a good video on this. Was this it?
In this video.
Yeah, this is the one. This one's pretty good. All right, so I'm gonna put this under instructor resources. And I'm just gonna go over like the basics of what a join is, because the video explains it in depth. So joins are pretty important. A join clause is used to combine rows from 2 or more tables based on a related column between them. So basically, if you had and I really briefly went over this on Saturday, again, because there's just no time. So let's say that we have a relationship between 2 tables, and this goes into relational databases. Now, this is where the primary key actually comes into place. So the primary key of an element, if it exists in another table, that means there is a relationship between these two tables. So over here, let's say that you had an orders table, and over here you had a customers table. So over here, you notice that you have this customer ID, and it says 23777. And over here, you see customer ID 1, 2, 3, whatever, right? So the order ID is actually the primary key of this order table. However, this customer ID, these are the foreign key of this table over here. So you're actually saying like, okay, well, I have this this table having these customers relating to this table over here. So there's a relationship where this table over here has a belongs to relationship, belongs to relationship to customers, I believe. Let me double check that. Okay, belongs to relationship means it belongs to someone else. Sorry, a customer belongs to an order. So since a customer belongs to an order, then the ID is over here, meaning that there is a relationship between these two tables. So you're saying, hey, I can then get information for all the orders, and I can say, okay, well, this order ID had this customer, this order ID had this customer, et cetera, et cetera. And there's also a has many relationship where you can have the same customer on multiple orders, right? Because a customer can have multiple orders. And so there's a has many relationship there as well. And yes, this is why it's called a relational database. So whenever you have this primary key, foreign key relationship, then you're going to see this, this information looking something like this. And in order to utilize this information, you're going to actually do something like this. You're going to do select, and this might look a little bit confusing. But for example, in this case, what it's doing, and let's just open it up, is it's saying, okay, select orders.order ID, customers.customer name, and orders.order date. Now, these are all just columns, right? But select them from orders, which is a table. Now, notice that I'm prepending each one of these with the table name, and that's necessary because we're actually accessing multiple tables. So we're not just saying order ID from orders, we're saying orders.order ID, customers.customer name, and orders.order date. So this column name is coming from the customers table, this order ID is coming from orders, and this order date is coming from orders. Now, I'm saying get this all from orders and inner join on customers. Now, where are we going to join these two? Join them on where order.customers ID is equal to customers.customer ID. So this is where we're able to use that primary key, foreign key that we saw over here and be able to combine those two pieces of information together. And it's a very simple query. It's not that hard to do. You basically say, get me it from this table and join it on this table, and join it wherever these two properties match up, or sorry, these two columns match up. So in this case, we have the same ID, but you don't actually necessarily have to have these IDs match up in terms of name. I could have just said customers.id, and that's if the customers.id, instead of having a customer ID column, it had an ID column. So again, we can stick with our convention of using ID instead of customer ID. However, over here, we can just keep it as customer ID because we don't want this to say ID and this to say ID again. That wouldn't really make any sense. So this is how we can combine our information together. And actually, W3 Schools actually does a really good job of being able to do this, because if I run this, it allows me to run SQL, and look what comes up. So now we find all the information combined together with all the different rows, and it shows all the different orders because we did everything from orders, and it gives me back all the different orders where the orders.customer ID was equal to the customers.customer ID. So again, that might be a bit confusing. The customer ID value the same for both table. So there there has to be a customer ID that really does exist over here for it to find a match in this table over here. Does that make sense? Like, you can't just put fake customer IDs in here and expect it to find all this information, right? So what we're doing is we're getting all this information from order ID and essentially populating all this stuff, because we don't just want order ID and order date. We want to know all the information of order ID, order date, and where the ID matches up with the ID over here, give me the customer name as well. So that's what we see. Notice that this customer name is coming from customers. So we're combining tables together and we're giving that information back. And if you guys are running with business analysis, this is going to be really common that you're going to do. It's like, hey, where's this person coming from? Age 35 to 40, you know, how many toys do they own? Why are they in this district, et cetera, et cetera. Yeah, it's essentially like, you know, one variable to another. But you're creating a relationship with those variables, right? So if I'm saying, you know, the ID of this customer has to exist in this table as well, because orders can have, you know, multiple customers, right? So, multiple customers can have orders. But in this case, it's a belongs to relationship. So there's a one-to-one relationship between an order and a customer. But if you wanted to, you could extend this as well and say, okay, I can have multiple customers have an order as well. And if you wanted to get additional information like contact name, country, all that from customers, you can do that. And this allows us to put tables together and really make our queries much more efficient. Because most of the time, let's just say that you wanted the order, right? You just need the order. You don't care about the customer. You don't need all this information about the customer. Because you might be thinking, why did I even separate this? I could just put this in here, the order and the customer and all that, right? So it's not really that. It's more like we need to separate these concepts from the orders and the customers, because they're two different things. And again, you could have the same customer, you know, making multiple orders, right? So you can then put like, you know, order ID is 10308, 2. Maybe 10310, 2 again. Maybe 10355. It has the same order, right? It might be the same customer is going to have multiple orders. And this is actually like what goes into really creating restaurant applications. They get really complicated. But they definitely use relational databases in that case. They should be in the same database. Yeah, you can query across multiple databases, but that generally doesn't occur unless you're trying to like really scale up information. And then that gets really complicated. So this is all in the same database. Again, these are just different tables, right? So the hierarchy is databases, tables, and then rows and columns within that. So again, I would highly recommend, because this is probably going to be really confusing. It's like there's so much about joins and all that stuff. So watch the 8-minute video, and then that will allow you to get a better understanding of the different joins that occur. And it should get you like, you know, start on, oh, okay. So it's basically just like, you know, populating information from one table that I have a relationship with, and I want to put that information to, you know, give that information to someone else, right? So I'm trying to just basically query and then find information just so that way I can see all that information. This is definitely used by video games as well. So you have characters, and then they can have like, you know, weapons and, you know, items, and items is its own table and all of that, and all these relationships between all these different things. And then characters can be part of a game table, and game tables can have characters. So these kinds of relationships really go really deep. And so we're going to try and cover those during the week. But I did want to just get you guys started off on thinking about these joins. And that's why it's only covered in such a short amount over here, is because it's just like, you'll get into it as you start using it. And you will start using multiple tables definitely by next week. So just questions about that on like a theoretical level?
When we're using these joins, how complete does our each table need to be? Because starting off, I might only know that I need this property in the table, and then later on, can I add more, or then we start?
Yeah. So it can be as complete as you want it to be. You don't have to have all the information. It's just like you can have one piece of information in there, and it'll just give you back that one piece. So whatever you're specifically asking for, it'll just give you back. Does that make sense? Like if I just had, where is it? SQL joins. So if I just had customer name and customer ID and I didn't have contact name and I didn't have anything else, I didn't have country and all that, that's fine. As long as I had that customer name that I was trying to make the query on, that's okay. Remember that you can always update your table. So if you did like an alter table, then you can update that information, and then you could later on get more information if you wanted. But remember, we're only asking for 3 pieces of information. So this column, and this column over here. And it's joining where these two are the same. So say that we want to add a column later on to add a new statistic or whatever. Could you retroactively add in values for previous column? Yeah, absolutely. So that's just like what Mario asked. It's like, can you add in, well, are you talking about values? Or, I mean, you can add in values or you can add in columns. You just have to change your SQL query. Because these queries are just made on the fly, right? They're not like, okay, I made this query and now I can never use a different query ever again. It's like, no. The database is also, it's static and it's dynamic. It's static when you create it, but you can change it, so it's dynamic, right? Now, the query that you can make is going to be based off of, like the information that you have at the moment, though. So if you're trying to get information that doesn't exist, you won't get it. But you can always add information to it, or edit existing SQL queries so that your previous clients can see it. And we did that at work, like all the time. Like, like a client would be like, now I want to see, this, and this on our analytics dashboard. Like, okay, we're just going to add that row or that column in, and now you can see all this information. Yeah.
So I guess what I'm asking, I think you might have just answered it, but like say I'm making an application that deals with statistics, and I wanted to add like a new category, like a new statistical category, and I wanted to like have it do calculations for me, or have something input calculations into a database.
Yeah.
But what you're saying, so I guess what you just said is like, then I would just I would update I could make a new column and then add it in for people that have previously been added to the database. Do you see what I'm saying?
Yeah. So you're essentially just saying like, okay, like let's say that so the question I think goes to more like you've seeded the database, that your users have started already coming in and they've populated rows, right? But there is no issue with you adding a new column to those tables for your customers, right? Because you're not changing their existing information. You're just adding a column to that piece of information. And then of course, if you'd have to populate that information again, right? So let's say that you're using an API through Facebook. Facebook allows you to get a lot of information in. You would just have to run this would be pretty complicated. So let's say that you got all the information. So what we did was, and don't hate me for it, like we would ask users when they come in to authenticate, and we get a lot of information from them, right? And then we would say, hey, we're going to be getting all this information. We're not going to be using it like on a personal level, but for marketing purposes, we're going to be using it. So we would get all the information in, but we wouldn't necessarily store all the information. I think we mostly stored all of it, unless there's like, some reason not to. So let's say that you only wanted to store a certain piece of information, but you got a lot back. But then later on, you're like, well, I actually need more information. So then you still have access on authentication on their information. So you could just make a query again to then repopulate only that column that you added, or only those columns that you added retroactively to your database of customers. and then that would populate. And that shouldn't affect any of the other columns because you're adding new columns and you're just updating those columns that you just added with the information coming from the like Facebook, Twitter, whatever API. Does that make sense, or does that answer your question or no?
Yeah. So even if the column didn't exist when previous Facebook users in this example were added, I can add the column and still add in information for them later on when I add that column.
Absolutely, yes. And you can even delete columns from those existing users too. It would definitely affect, you know, your queries if you delete information. But you know, we have done that. It's like where we don't need a row, or let's say a column that's like, you know, that's never used, but we've been like, you know, just storing it every single time. Like maybe it's the amount of tacos one person eats every 23 days. For some reason, we get that information. We can just get rid of that entire column. Okay, are these joins affecting the structure of the database? No. So that's a good question. So John's asking, are these joins affecting the structure of the database? Absolutely not. These are queries made just to get information. Notice that it's just a select, right? So you're just doing a read of the database. Now, you're not creating anything new. You're just getting information out. And you're just saying, here, give it to me. But it's really important because I've done this a lot, and it really doesn't necessarily have to do with programming, because this is very much a marketing or business analytics or statistical query that's done a lot across, you know, a lot of different applications. So if you're using like, you know, MS Server, things like that, or Excel, this is one way of getting information across multiple things and getting only the information that you want. So again, statistical stuff, business stuff, a lot of that happens with joins. You can use joins. Generally, it's not used for like adding. For adding, what I do is I run like a migration or seed. So what I was talking about was like adding information to a table. First, you alter the table, and then you seed that information. So you don't use joins for like, it's mostly just for reading information. I haven't seen a join being used for adding information, because when you add information, you're not combining tables first and then adding it there. You can, like, let's say that like you can use a join first to find all the rows that you want to add information to. So like find all these IDs, and I'm just going to add information just to these IDs. So you use that join to find, you know, and specify just these IDs. So you do a join where this is equal to this, and this has a relationship with this table, and only there, give me those IDs. Okay, now you have the information back. Now on these IDs, now update and alter the table and add information to that specific column. Not multiple databases. So is it accurate to say that join is a way to retrieve data? It is it is accurate to say for multiple tables in one call, or for one statement, but not for multiple databases. Okay, but I highly recommend, again, watching the video, because I think we spent, again, too much time on one concept, and I really want to get into the next one. So Server.js, we've gone over callback functions and promises, but we haven't really gone into how they work and how to create your own. And it's really important because asynchronous callbacks, you know, the way they're created, or callback functions in general, how they're created, it's actually pretty simple, but it is confusing when you first look at it. So here's an issue, right? So this is an async problem. So we're making this call, and we do this select where, and then we console log the data, and it says data is undefined. So why is this data undefined? We made this call, and then we're asking for data. And if you want to take a look at here, So why am I getting data undefined? I'm executing this file over here. So it's running from top to bottom. I got the data, right? So I should be able to see this data. Why is this data undefined when I execute it? Shouldn't the console log be in the bottom of the file? The console log is at the bottom of the file. Why am I not seeing this? Bottom of the screen. Huh? Not at the bottom over here, but the console.log. Well, okay, so where would the console.log work if I were to put a console.log? Or better yet, how can I make this console.log statement show the data? I want the console.log statement to show the data inside of server.js. Because yeah, if I did put it on like, line, well, if I did on line 9, then they wouldn't do anything because I'm doing a return. But if I did hit here, yeah, it would probably show it to me. But I want to show it here. I want to console.log all the information here. Yeah, I could add a promise, but this over here, does it have a promise? This is just a method. No, JSON.stringify wouldn't give me anything. That would still give me undefined. Promise was pretty close though. Callback, yes. So I create my own callback. So to create my own callback, remember the holler back rule? Juan does. So we have this callback function. And you might be thinking, it's like, wait, that automatically worked? Like, how does that work? Remember, before we had no function with result, and we were calling this, but I added this function result, and automatically this stuff seems to work. Well, it's not actually automatic. We actually had to do something like this. All right, this one's going to be pretty confusing. So if I have server.js and orm.js, and if you guys are following along with the files, this is number 6. Sorry, the solution is number 8, I believe. Let me see. Solution is number 8, yeah. So we're looking at the solution, and over here the solution was, let's see. Nope, this still isn't it. Where is it? Here it is. Okay. And this is the old server.js, so I'm gonna put the new one. So the solution is to, instead of just have 3 parameters being set inside of select where function, you instead have 4. And the 4th one is just a parameter called CB. That stands for callback, right? And that is just a parameter we set, right? It doesn't mean anything else. It's just whatever we set over here. Now, we do the same thing, query string, blah, blah, blah. We do the connection. We execute it. Remember, this is a callback function that's built into connection.query. But notice that we then call this CB and then pass in result. And result is coming from here. All right? So I'm going to change this to res just to not confuse everybody. And what we're going to do is we created our own callback function. And you might be thinking, it's like, wait, this is hurting my head. So we actually added the ability to pass in a function as an argument. But we didn't really do that. We always had the ability to pass in a function as an argument, but we haven't really done that much. So we're creating our own ability to pass in a function as a callback. So what happens is this is a function that we're executing. It's kind of like recursion. You can think of it like that, because but it's not really calling itself. If it were to call itself, the select where would be here. right? So instead of recursion, you can think of it more like passing in a function to another function. All right. So recursion is more like calling the function within itself. Now, if you have this CB result being passed in over here, then this is being executed. You might think like, where the hell is this result coming from? This is an argument we're passing to it. Oh, this is actually coming from this callback. So this information already existed. We're just putting it inside the execution of our callback. So when we pass in this function will then take in this result. So the execution, the way it works is, first off, this gets placed into the file. Then we execute this. So we execute this. It calls the select where, which is going over here. And we're passing in 4 arguments. So what are the 4 arguments we're passing into this method? Yeah, so, all right. So you just write down exactly what's being passed in. So table input is going to be replaced with what? This is just, again, this is just a function. So table input is being passed in and it's being replaced by, yeah, but what's the parties? Yes, parties. Then column to search is party type, yes. So remember, this is a one-to-one relationship. Value of column, grown up, yeah. So CB is what we predefined, remember. Now, we are just, it looks like this is a function definition, but we're actually passing this function as an argument. So this, just like all these other arguments, are replacing this variable. So now, when we see this variable, this actually represents function and then result. So it's actually being passed. So this, and it might seem kind of confusing. It's like, wait, I have this res, and I also have this result again. It's like, oh, this, even though these are setting up parameters, this result is populating this parameter over here, res. So it's going the opposite way now. So now when we call the function, it's actually executing this function and populating it with the result. So now res is actually result coming from here. So it goes back to here, and then we have the ability to see the data. And we didn't have to do this. We could just see console.log res. And that's how you create your own callback function. All right, so this is hard. I want you guys to really open up this file and talk about it for like 5-10 minutes, because I want you guys to play around with it, make your own, callback functions, and you don't even have to add it as a method or anything. Just start messing with it, and I'll come back in like 5-10 minutes and check up on you guys. The function, yeah, this could have been anything. I could have passed in whatever I wanted. I could have passed in butts, but then this wouldn't work, right? It's an argument. So this is an argument this is a parameter that's being replaced by this argument, but I could have passed in whatever I wanted. It's just that it would run into an error at that point. All right, so unmute yourselves and discuss.
All right, so who has the best understanding of it?
You guys are funny.
What's up, dude?
Hey, I wasn't paying attention to any of it, but I guess we can figure it out. Where's the file? What
It's
file is this?
number 8, the asynchronous solution.
All right. Number 8. Okay. We're looking at the ORM and the server.js. Which sublime and the ORM. All right, so connection.js. All right. Party type grown up. Callback function is the result. Select where. Okay.
All it is that
That's
we're
pretty cool.
passing a function as an argument that we're not using until line 8. Until line 7 executes, we don't use the fourth argument in the orm.js, right?
Until the what executes?
You know, so
line 7?
there's 4 arguments in line 4. Parties, party type, grown up,
Yeah.
and function at least doesn't execute until connection.query runs. Well, after it returns a result on line 8.
Yeah.
Does orm.js is that run before server.js?
No.
Because then
Actually, yeah, it does, because that's it's the
right because
well,
then,
no,
otherwise the function would come back as undefined.
no. Server.js actually runs first. ORM.js runs on line 1 of server.js.
Server.js is the first file that executes everything in the branch.
Yes. So server.js runs. It requires orm.js, which is then opened up. Then it creates a connection at line 1 of orm.js.
So orm.js runs before that function runs.
Before the function, yes.
Okay. That makes sense. Because then you get that result to then be input into the function.
Mm-hmm.
Correct.
Yeah, that makes sense.
It's just the only difference. Instead of using strings and I guess integers, now we're using functions in place of arguments, right?
Is the callback part the confusing part for you?
Oh, I think Omar just wanted to make sure we had a good understanding.
That's data, not function.
But that does make sense.
Oh, so this part, the select where as a function, is that the part that's confusing for John?
John, do you have a microphone you can talk to us through?
Sorry, I don't have a question formed. I'm just trying to figure it out.
So what part of the problem don't you get?
You know, I'm wondering now if this CB result is a special shorthand that's unique to whatever.
CB, okay, so CB is actually declared at the top in the function call. In line 5, select where, at the very end, it is, it's defined as CB, but it can be named like callback or hollered back or whatever else you want to name it. Yeah.
Yeah, on line 5, it has 4 arguments. It has table input, call to search, vol of call, and it also has one called CB.
Yeah, they can all be named whatever you want. Result, likewise, in line 7 can be named res if you want, or whatever else you want to name it. But basically what it's doing is it's running the function that was declared in line 4 of server.js.
In a way, it looks to me like a shorthand for like a move result to CB.
Yeah, that's kind of the idea. So you move the result and you return it. That's the callback function. You know, you're returning it for whoever's on the receiving end.
Hey Omar, we can see your screen.
Yeah, that's fine.
Right.
You guys can see it, right? That's fine. I'm just talking to one of my students from the other school I taught at.
No, that's cool. I just want to let you know. Wait, guys. So here's a question for you. Since it runs, since orm.js is running first to run that function, then how does ORM get the other parameters?
Because it's being passed in parameters to begin with. I think there was parties. It was looking at what table, what IDs, you know. So when you use the ORM, the method right there, you have to input the values first. And the fourth value that we input was the function.
Right. That I understand, but that's running before. Or isn't the other one? It doesn't get that information before it runs, I believe.
Yeah, it doesn't get the information.
So then how can it run? You see what I'm saying?
It's
Like it should be able to. Like I understand the premise of how the function runs.
It's kind of like,
Hey Omar, is there any way that you can go back to the other screen?
Oh yeah. Yep.
Thank
You
you.
guys have this, right? You guys have 8.
Yeah, but I can't. I want to be able to type at the same time. I don't know.
it's kind of like in homeworks when we define the function and then on the bottom we call the function and we input certain values. That's kind of the same way I see it, where we define the function on orm.js and on server.js, we're calling that function again and putting argument values into that function. Do you know that, Jared?
I'm looking. Oh, so OR. That makes more sense now that I just changed, but that made sense a second ago. Because he's only calling select where in that statement, and then he's inputting all those values, and the last value is the function. That makes sense.
Who is power user?
Oh, damn it.
Cool. So who's power user? Tom Miller. Oh, okay, got it. So Tom, it has to do with asynchronous calls. Usually, if you're running into an undefined, and your computer's calling. So yeah, usually it's the asynchronous calls where you don't get the data back yet. So that's why we, with asynchronous calls, you always have to make sure that you're using a callback that then resolves that asynchronous call. Remember that with synchronous calls, you wouldn't need to do something like this. You wouldn't need to have a callback function. With a synchronous call, everything works by doing one thing at a time and then going from line to line. But the asynchronous call, it will execute from top to bottom, just like it normally would, but it doesn't wait for the results. So if you then say, okay, well, I want this data, it's like, well, it's not there yet, so it's going to say undefined. The joys of using programming on the web.
So Omar, so if you don't mind me just going through it, like very dumbified, like just the process of how the information moves.
Mm-hmm.
It goes from ORM, so then you're selecting the method, select where. You're passing in party type and grown up into the select where on orm.js, yeah, over there.
Yeah, and you're also passing in the function as well.
And you're passing in the function, but how come the function only, wouldn't that make the function run? Oh, the function only runs once it's called in the query, connection.query, right?
Yes, so you're saying that, okay, so now this function will execute. So this function will then execute as soon as you're calling here, it gets populated with this result after this is done. So this itself has its own call like this. Do something like this as well.
Okay, so CB result then becomes res.
Well,
Right? Hey,
well, essentially this.
Daniel, can you
so-
mute your typing? It's kind of.
Sorry about
Oh, God.
So res is basically the same thing as this. Now it's replacing this, right? So this is going to be here, but now you have this variable that was passed in. Now that actually gets populated with the real value, which is result. So then this result then goes into here. So now you're executing this function with a real value.
Yeah, that makes sense. So result is then going to take over for res on line 5 of server.js.
Sorry, I'm reading things at the same time. What was it?
That's okay. So CB, the result of CB is then going to take over the value on line 5 of server.js.
Yes. Yes, correct. So that's essentially you're just saying like, okay, now once this is done, pass it back to this callback function, and now you have this res available to you.
Okay, so you're sending it. Geez, it goes back and forth. Okay.
Yeah. So the fun of internet, like I said. Yeah, web development's a lot more confusing than just using it like in a compiled language or something. All right, you guys ready? Bueno. All right, so now let's go to the MVC. We have server.js, and I'm gonna get rid of this. I'm just gonna do layout, single layout. And notice that my server.js is a lot smaller now. So this is an MVC example of me modularizing my application even further. So I had my application look like this before. You guys see on the left-hand side of this holiday planner where I was, let's see if someone's breaking into the house. Nope, it's just this fun. Yeah.
Now you cook food if you want.
Oh, cool, thanks, man. Dude, I think someone like opened the door randomly and then left.
Might have just been them getting confused.
Oh, okay, cool. Just random people or people you know?
No, yeah, Dr. She's chill.
Okay, cool. All right, so no one's trying to break in the house. Cool. So we have this application, and we further modularize it to look like this. Now we're further modularizing it to be even easier to just scale out using this MVC model. And MVC is just another concept, similar to how ORM is a concept. But MVC more so because it's very much like how you want to structure the application, and how applications can look. Now there's different applications that implement MVC, including PHP does it a lot. With Rails applications, it's built in. Django I think has it built in. So most of the I think the majority of applications out there actually that are large scale are using this MVC concept. And the MVC concept goes into model view controller. So hopefully you guys saw that video I posted in Instructor Resource. It's pretty short. It's not too long. Let's see, how long was it? A few minutes or something like that. I don't remember. It wasn't too long. And so we're using it again, not as something functional at this point, but more as a way of scaling our application and making it so we have this separation of concerns. So we're not adding any new functionality to it. We're just saying, hey, we're going to process and do the same thing, but while at the same time making our application in the long run easier to use and easier to manage. So in this application, you'll notice that we have, again, we're using our modules like Express, Body Parser, Method Override, and we're using this app Express and this middleware, and again, more middleware over here, and we're using our templating engine. But then after that, we don't have our database stuff, and we already modularized it. So where did we modularize our database stuff? I thought it was here. So if we check controller, so Jared says controller. That doesn't seem to be database stuff. Yeah, there's some database stuff. Let's see, DB. So we have our SQL files in our database folder, but that doesn't seem to be where our connection information is. Is it models? I don't think so either. We actually went over this in number 5, configuration. Yes, so under configuration, we had our connection.js. So that is our credentials for accessing our database. So if we go to our credentials, remember, we're just storing where we want to access information from. So, or how to authenticate into our application, and how we authenticate into it is from config. It's okay, you don't have to be embarrassed. It's just, getting used to this format. So, so we have all of this connection information in here. And again, we're utilizing it over here. Just, we're doing the same thing over here as well. So we have our connection and we have our ORM. So we have the same thing, but this ORM is a little bit more complicated. Now, we're starting to get into a little bit more of a longer query, more queries available to our ORM. We're doing some helper functions for printing question marks if we need to do that. So our ORM provides us with some nice little helpers. So it allows us to, convert an object to SQL, allows us to have methods, allows us to do a whole bunch of stuff. So our ORM is basically our ability to then make queries and have helper functions to make these queries as well. Now, if you look at our server.js, notice that we also have something called routes. So far, we've only gone over a couple parts. We've gone over that we can have this config. We have our ORM. I don't want to go into controllers and models yet. We have our DB. We have our SQL files. And we have our views as well. You guys already know about views, right? This is where our templating engine and all of our, anything that gets displayed to the user is located. We also know about public. This is where all of our static assets appear, right? So any JavaScript files that are just for the front end, any HTML that doesn't require any processing, just putting it in there. Remember that for static files, that's all coming from app.use, so middleware, and then we're just saying, okay, current working directory and then public, so make sure you access it from here and it'll go down to public, and that's where all static files will be rendered. So questions before I move on to routing. This should all be review up to this point. Wait a few more seconds. CSS goes into public. Views are what's displayed to the user, meaning like through a templating engine generally, not static assets. So views are generally like generated or processed views. Okay.
Hey Omar, would the static CSS go to the file before it hits views so that the user can get the CSS?
So good question. So what actually happens is you just have access to this to the CSS once someone actually is on the HTML page that's requesting the CSS file. Remember, if you have something like this, then what's happening is when they receive this file, this is a view, it's being sent back to the user. Now, when they access this file, they get this HTML, right? So it goes from top to bottom. So this gets processed by the browser, and then this gets processed. So remember, it's linking to your CSS. So it's making a request to your server. However, that is all inside of public. So it just gets returned back to you. Once this is done, then it goes to this part, and then it goes down and down, down and down. So it actually works in the same way, except you're hosting it on your server. And like you're doing this on your own server instead of someone else's server.
So we're allowing them to have it load from our server.
Yes.
Right as the page loads, and it won't load for us, for example.
I mean, what do you mean by load for us?
Like it won't load until they open up the page. So it's going to be they're making their own call to our server. We're not putting it in there for them.
Correct. Yes. So we're not sending it automatically back. They are making a request when they get this file for this, which is done through the browser.
Got it.
All right. So now we have our controllers. So you have this variable called routes, and it's requiring this controllers, cats-controllers.js. Well, remember, this is just requiring a file, right? So it's going to dot, which means our current directory. So go to our directory, go to controllers, go to cats controller. Sorry, neighbors are loud. And then we have all this information here. We're like, oh crap, what is all this, right? But this is actually just where our logic resides. And this is the logic for our controllers. So there is some debate as to whether you should have fat controllers and skinny models or skinny controllers and fat models. That just means like, should more code and more logic exist in the model, or should more code and logic exist in the controller? I always say skinny controllers, fat models, but we're just gonna go with that, which is the Rails way of doing it. So over here is our controller. Our controller is essentially our access point. You can think of it as when the router is saying like, okay, I need to perform certain actions at this specific location. Then I'm gonna go to that path's controller. So this is just one controller over here. You're generally gonna have every controller map to some model. Now, don't worry about models yet, but generally you're gonna have as many controllers as you models, and models are representations of tables inside the database. So if you have this controller over here, so let's say you have cats-controller.js, then you have the ability to say, oh, okay, well, this has everything to do with the cats model. So I'm going to be using the Express router, which only deals with routing. So it's the same thing as using app, except instead of the whole Express application being used, you just use router. Because we don't need to use all of Express for routing. We just need to use the router aspect of Express. So when we just use the router, it actually ends up being less, memory intensive. So less costly in terms of memory. So we require Express. Instead of instantiating or running the whole of Express, we just run the method router on this Express, right? No, so static is the only piece of middleware built in. Express has a whole bunch of crap built in. Express, and what you're thinking of static is the only middleware that is predefined inside of Express. So router is not a piece of middleware. This is something that's meant specifically outside of middleware, which is routing. So we are now importing the model, and we're going to get to the model. But what happens is now you can do the same thing that you did before. So depending on which route was hit. So let's say that you did a get on, just the root path, then it's going to go to this one. So if you did on root path, then you can just do .get, .post, .put, all of that, and it's just this, right? So from here, we can then access, our methods available to us, and then it'll perform that through our controller onto the model. Now, I'm wondering how to explain this without first explaining models, but this is going to get really confusing. Okay, think about it this way. This is the logic that we executed before inside of our ORM. So we had all of these predefined, and on our server, we just executed. Now, we're not executing from the server, we're actually executing from this controller. So execution of information and the logic of execution occurs in our controllers. So first we say, okay, for anything that's a path that goes to, let's see, just, I don't know, /, so our root of our application, go to this controller. And this is a piece of middleware. So it's going to say, okay, we need this, so we're going to require it first, but then whenever it hits anything with a /, go to this specific routes file. Now, you're going to have multiple of these. And the way I've structured it in my application, you're going to see later, is much easier to understand when we get into scaling it out. And that's the way the curriculum does it as well. They just wanted you to have less of it in the beginning. Yeah, so basically it's just saying, hey, if you're going to this path, go to this file. If you're going to this path, go to a different file. So instead of all of your routes on the server.js file, so before we had all of our routes on our server.js file, right? All this crap. Can you imagine if you had like 1,000 different routes, like a 1,000 different paths or something? Like, a whole bunch of different paths. One for like root, one for like, about, one for like, information page, one for everything. It gets insane, right? You would not be able to scale this by putting this in one file called server.js. So what you're doing is you're actually modularizing that now, okay? So you're modularizing it into routes. So in this case, we only have it in one file, but later on you'll see that we're actually gonna set up a file that takes care of all the routing everywhere. So if you go to /, it'll go to one controller. If it goes to, whatever, something else, it will go to another controller. Goes to something else, goes to another controller. So controllers in this case are just saying like, okay, you have the route, go to this specific controller, and this will take care of the logic for you at that path. Okay, and that controller will have all the different routing logic taking care of it for you as well. So in this case, we have our routing logic within our controller. So we've gone here, and everything with / is in here. So notice that I can do router.get, and then this is going to start doing all the logic. So it's executing this function, and it's going to do res.render, and it's getting all this information back. And we're never really connecting to the database, though. Again, we're not interacting with the database directly. Now, we're having the controller interact with the database through the ORM, right? So we have this cat.all, and this cat.all seems to be coming from this model called cat.js. Yeah, it's basically a walk around from Disneyland one land to another and just not through the main entrance. Exactly. So you're separating everything out. Again, we're doing the same thing over and over. We start off with the same shit. Everything in here could have been in one giant file. We're just separating all that crap out, right? So functionality, same. Separation, that's the difference. So, and I'm trying to take it step by step without like overwhelming you guys. So if I like step back and be like, hold on. It's more like I really don't want to get too deep into it without you guys kind of feeling like it's overwhelming or anything like that, because this is a lot, and this is a really important concept to cover. So we have this model now, right? And this model is coming from, if you take a look at models, Cat.js. And I feel like it's one of those things that, yeah, it's definitely, I mean, this is just preparation for this week. So if you don't understand it, don't worry about it. It's just prep. Like, I was only supposed to cover this for 10 minutes. But I really want to get into like a little bit more in depth, just so when you guys get into it on Monday and Tuesday, then you're like, oh, now I get it a lot more, right? So if you look at the model, notice that we're now using the ORM, right? So our ORM is going to be Sequelize. We're using a custom one right now, but we're going to be using Sequelize. Now, this is a table representation directly of the database, right? Or whatever table we're using at that point. So cat should refer to the cat table. And these are the different methods that you can use on the cat table. Now, whenever you use anything from the model, it should have the ability to do the 4 different CRUD operations, right? So read, update, destroy, create, all that stuff. But it's not doing it directly. So instead of running it directly, it's actually running this ORM. Now, we're actually passing it, again, a callback. So we're saying, okay, as soon as this is done, this is going to execute this res. So we're actually passing in a callback to this all method. Okay. Yeah, the MVC video is really great. I think I also posted like some map in class in like 2 seconds, but that was really crappy because I was just in a hurry. But the video really does a really good job of explaining this stuff. So we have all these different things. And honestly, the really hard part is that I'm explaining this in a conceptual level without really having any real implementation. And when you guys start using it, then it's like, oh, that makes sense, right? And what I'll do is I'll whiteboard this from 5:45 to 6:30 as well for both of your guys' classes. So for Monday and Tuesday. So cat.js we're using inside of our controller. Where's our controller? So if you have our cat's controller, notice that we're using this cat.all and we're passing in as an argument this function. And this data is going to be populated as soon as this method is done executing. So we're saying, okay, this data is going to be populated as soon as this is done executing. And then we have our console.log HBS object just for ourselves to make sure that we have the information in there. And then we return this information as a response back to the individual. Shoot, I should have used a drawing tool for this. Apologize for that. I think I would have done a really good job of explaining that. But I think, again, if you guys come early to office hours Monday and Tuesday, again, I'm going to do the review of the last class. And I think mostly what I'll go over is MVC. Because without really drawing it out, you can't see where all the information is going and coming from. And that gets a little bit confusing. But really take out of this that all we're doing is not adding new functionality. We're just modularizing it so that only certain parts are talking to certain things. And we're making it so this scales the application really well. So the model is only talking to the database and to the controller. The controller is only talking to the client and the model. And the client is only talking to the server.js, right? So server.js is going directly to the controller. I mean, you could say the server.js is part of the controller, but essentially it's a little bit different in this case. So there's a lot of modularization happening. So you can have this separation of concerns. And so if I mess up anything in Cat's controller, it doesn't really mess up everything everywhere else. And also, so we can then have multiple people working on this application at the same time without really stepping on each other's toes. We can have a lot of things being added to the application without working on this single server.js file, right? And that's essentially it. I really don't want to go too in depth. I'll try and go over this concept again with a nice whiteboard so that everyone can see it. Maybe next time I'll use like a drawing tool so you guys can see it, but I think my drawing's gonna be really shitty if I use it on a computer, to be honest. So I think doing it in class, just as model view controller part, would be really important. So we also have some more examples of using model view controller. So we have this one. This is, again, cats. We have another cats application. Do we have multiple controllers? No, just one controller again. Yeah, so this one's using partials. Don't worry about partials yet. We'll cover that in class when we start using partials more. But I think actually partials are pretty important. So partials allow you to split up your pages into different parts. Like, let's see. So this is a partial for the cats application. So let's say I have this index.handlebars file. But I also wanted to include maybe this piece of HTML with some JavaScript in it, wherever I needed it. So partials make it really easy to just put in different parts of the application into another file. So instead of me having to manually put in all this information, essentially I do the same thing as I do with the function, and I just require it. And I just say, oh, okay, well, I'm just gonna put all the information that was inside of this partial now inside index, and I can call this wherever I want. So I'm modularizing this further so that I can have different components whenever I need this. And this is really important, especially as we get to React, what the concept of all this is. Oh, the caret, I believe, refers to including a file or a partial. So this is saying, hey, include this file in here. So it just looks automatically inside of, let's see, the partials folder, and it then looks for cats, and then it looks for whatever you set it. So delete cat. So this is pretty simple. It's just splitting up your handlebars files into different files, and then just including them wherever you want. So I have my main file index.handlebars, and then I can just see my delete.handlebars like that too. See what this looks like. Do you mean me executing it? It would literally just show up as the whole application. Like, it wouldn't show up different, like in different parts. Like this would be included in this index, which would then also be included in this main. And then that gets rendered as HTML, which then gets sent back to the client-side application. Does that make sense? All right, I think I should open up for questions because I think you guys are going to have a ton of questions. Then I got to go. What are some good ways to partial it out? So what I do is generally I partial out the navigation, the footer. I'll partial out things like that, like files that are meant to be partials, that are supposed to be part of applications, like components. React actually does a really good job with this, with everything as a component, and you just put these components together. But with most server-side applications, you're gonna have like main files, like home, and index, about, all these other different kinds of pages, and profile, and you're gonna have some parts that are always gonna be there, like your navigation. So and this delete is gonna be there again and again. It's the same. So why not just reuse it, right? So instead of having to include it over and over and copying and pasting it, now I just do this. And that's it. So again, there's no functionality change. I could have just put all this information in here. It just would have made this file longer. But let's say I had multiple files that needed a delete cat. It's not dry, right? Do not repeat yourself. So we're doing a lot of modularization and do not repeat yourself kind of stuff, right? No new functionality is the key here. It's essentially just modularization so that we can have scalability and separation of concerns. So now's the time to ask questions. We're good? Could you have file with the handlebars and wait, could you have file with what the handlebars and ORM replaces just so I can see the difference? Replaces? Wait, what? So Ben, could you have file? What is file with what the handlebars and ORM replaces? The script file? You mean like what's gonna go inside here? So okay, so what's gonna go inside of here is gonna be coming from index. So let's see, our controller is gonna hand back this HBS object. So this HBS object is being passed into index, and that's coming from the database. So in reality, I think one good way to think about this, Ben, is like saying like, okay, so I made a call. I asked for the root application, right? So that went to my server. It went through all of this, and then it went here. Oh, crap. It went here. Now it went to my controller because I said, okay, anything with this, go to this controller. So it goes here, and it's a get. So it just goes here. And then it makes a call from our model using our ORM to our database. Now our database gets that information back. It gets a array of objects, comes back. That information is now put into an object. That object is then passed in to our handlebars file. Now that handlebars file then renders all this information. So you have that object and it's populating all this information. It's putting it in here. And then, you have this delete and that's getting populated as well. This gets populated. And then you have this being sent back as a response back to the client. And you get that information. And this is all done within milliseconds. Hey, Brian, if you want to get prepared for next week, check curriculum resources and go under Sequelize. There's a series of videos. And Ben, did that answer the question about what's happening? Templating is good for scale because you're not just passing everything in with one file at a time. You're having multiple people go through it. You have multiple files that you can then pass information to. So it's, if someone's working on the front end, you have the ability to just work on the front end. If someone's working on the back end, you can have them just work on the back end. And templating, you're not repeating the same code over and over and over. You just have templates for where the code will go. Yeah, so it is confusing, and this is honestly just prep, again, for Monday and Tuesday. So if you guys are not getting this, it's not that big of a deal. So let me send this out as well. So if you guys are interested in Sequelize, these are a great series of tutorials. This guy does a really good job. And it's only like 6 videos, and they're pretty short. For sure. Good luck, guys. If anyone has any questions, let me know. Again, you shouldn't be saying like, oh, I need to understand this 100% before tomorrow or Tuesday. It's more just like, this is just extra help before we start getting into the stuff on Monday and Tuesday. So we're going to be covering this again, and then we're going to be using Sequelize and all that stuff. We're not going to be using our own custom wrap. All right. No worries, guys. Take care, everyone. Good night.